Hi guys, today we continue talking about different forms of quadratic equations, and today the topic is vertex form. So we've already had kind of a two-day introduction to vertex form, and then the last set of notes we really focused on standard form, but today we're going to talk about vertex form. Remember, in vertex form you have your a value, which will be replaced with a number, and then you have your h and k value, which actually give you the vertex of your quadratic function. So I'd like for you to pause your video, take a minute, maybe you can reference some of your notes that have vertex form on them, and I'd like for you to fill in the blanks as much as you can on the front page. So take a moment, pause your video, look through your old notes, and try to fill in your blanks. Check back when you're done. Okay, so filling in the blanks should have been kind of familiar because a lot of the blanks are very closely related to what you filled in yesterday. Today, because we're talking about vertex form from the equation, you need to identify the h and k values from the equation and put them together to make the ordered pair for the vertex. The axis of symmetry, again, is the x value of the vertex, so from here, and you would write it as x equals, and then whatever that x value is. The maximum or minimum value is the y value of the vertex, so it's located right here. You write it as y equals, and then the y value. If you're looking for the y-intercept is located where x equals 0. You can always substitute 0 in place of x in the equation, and you can solve for y. You write the ordered pair for the y-intercept like this. And then finally, the only thing that's really different is whenever you try to find the x-intercepts, it's still where y equals 0, that's where it's located on the graph. You substitute 0 for y and solve for x, but you will probably need to change vertex form to be standard form, what we talked about in the last set of notes, the ax squared plus bx plus c. And the reason you need to make standard form is you need to be able to solve by factoring or quadratic formula or even completing the square. And I didn't underline that because I feel like most people won't choose that, but these two are a little bit more familiar. And you write your x-intercepts again as ordered pairs, the root, comma, and then 0. So we're going to go on to the next page. And we have our vertex form for our equation. We have y equals -4 times the difference of x and 2 squared plus 4. So one thing that I notice is that my a value is -4. And what does that mean about the direction our parabola is opening? That means that our parabola is going to open down, because a is negative. So it's going to end up looking like that. So this again is because a is negative. It's a -4. What about the vertex? Remember, the vertex is the h and the k. And also remember, everything in parentheses is a lie. So instead of writing my h value as -2, it's actually +2. And my k value is 4. So there's the vertex. I'd like to find the axis of symmetry. Remember, the axis of symmetry comes from the x value of the vertex, so x equals 2 is my axis of symmetry. And my maximum, because my graph does open down, so my vertex is going to give me a maximum value. My maximum comes from the y value of the vertex. So y equals 4. I want to find my y-intercept. Remember, the y-intercept is located where x equals 0. And we've talked a lot about how when you have an x value and an equation, you can substitute that x value for x, and you can find the corresponding y value to complete that ordered pair. So that's what I'm going to do here. I have y equals -4 times 0 minus 2 squared plus 4. So 0 minus 2 is -2. -2 squared is 4, so I have -4 times 4 plus 4. It's a lot of 4s. -4 plus 4 is -16. And negative 16 plus 4 is negative 12. So that is my y-intercept. The next thing that I'd like to do is I'd like to find my roots, zeros, x-intercepts, solutions. Remember, all of these are synonyms, so they're all going to come from the same work. Now on the front, it says to find the x-intercepts, you want to substitute 0 for y, and then you want to get this in standard form. So that's what we're going to go ahead and do right now. I have a box above here to translate to standard form, so I'm going to go ahead and do that. And then once I get standard form, I'm going to go ahead and find my roots by either factoring or quadratic formula or completing the square. So my equation in vertex form was y equals negative 4 times x minus 2 squared plus 4. Standard form doesn't have parentheses, so I'm going to try and get rid of those. I'm going to write x minus 2 times itself because it's squared. And I still have the plus 4. If I do FOIL here, x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. And negative 2 times negative 2 is plus 4. And then I also have that plus 4 on the end. Notice that we still have this minus 4 out here, and it needs to be distributed. So negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x is plus 8x. Negative 4 times another negative 2x is plus 8x. Negative 4 times positive 4 is, minus 16, and then plus 4. So if I combine my like terms, I guess standard form will just kind of hang out under the standard form box. I've got negative 4x squared plus 8x and 8x, that's 16x. And then negative 16 plus 4 is minus 12. So there's my standard form, which actually is something that we have on the bottom that we're asked for. So I'm going to go ahead and rewrite that here because it is part of our problem later on. Okay. So if I want to find my roots, I can either factor or I can use quadratic formula. It doesn't matter which one. I think I'm going to go ahead and factor. I'm going to divide all of these by a GCF of what? Negative 4. So 0 equals negative 4 times x squared. 16 divided by negative 4 is minus 4x. And negative 12 divided by negative 4 is positive 3. I need two numbers that multiply to be 3, and at the same time they need to add to be negative 4. Maybe negative 1 and negative 3. So my factors are x minus 1 and x minus 3. And remember that your roots are the opposite of your factors because everything in parentheses is a lie. So I have x equals not negative 1 but positive 1, and x equals not negative 3 but positive 3. So I'm going to go ahead and write those in as my answers to all of these. Okay. Remember that for your increasing and decreasing intervals, we talk about the x values, that the graph is increasing or decreasing. I'm going to go back up and look at kind of my little sketch here. Remember that the axis of symmetry was x equals 2. So what's happening on the left side of x equals 2? all the values of x that are less than 2. What's happening to this graph here? From left to right, it's going up, right? So that's the increasing interval. It's all the x values that are less than 2, to the left of 2. And then what happens once it hits the vertex? It starts to go down. It starts to decrease. Those are all the x values to the right of 2. We say that those are the x values that are greater than 2. And then our domain for a parabola is always all real numbers unless we have kind of end marks, endpoints. Our range comes from the maximum. So if I look at the maximum, right here it was y equals 4. So look at maximum or minimum if you had a minimum value. So all of my y values, well, they don't go any higher than 4 because the maximum is y equals 4. They're all under 4 or equal to 4. So that's all the y values that are less than or equal to 4. And finally, we need root form. That's the last thing that we need. And so if you remember from the last set of notes, we were able to just substitute values in here. So our a for this problem was -4. One of the roots was 1, and another root was 3. But you'll also notice that in the process of finding the roots, we actually found root form because we factored. So this is y equals -4 times r minus 1 times, oops, sorry, not r. What should that be? That should be an x. So x minus 1 and x minus 3. That's my root form. So you can literally take your values that you have already found and just kind of substitute them where they belong.